Welcome to chemistry class. Today we will discuss group 14 elements from P block elements. P block occupied group number 13 to 18. Group 13 contains boron, aluminium, gallium, indium and thallium. Group 14 contains carbon, silicon, germanium, tin and lead. Symbol of carbon C, silicon Si, germanium Ge, tin Sn, lead Pb. Atomic number of carbon 6, silicon 14, germanium 32, tin 50, lead 82. Electronic configuration of carbon: helium followed by 2s2 2p2, silicon neon followed by 3s2 3p2, germanium argon followed by 3d10 4s2 4p2, tin xenon followed by 4d10 5s2 5p2, lead krypton followed by 4f14 5d10 6s2 6p2. So moving down the group, inner pair effect will be increases due to poor shielding effect of d and f orbital. Example: lead contain both f and d orbital. D and f orbital having poor shielding effect, it attract the electron more firmly. So this 6s electron do not involved in the formation of bond. So most stable oxidation state of lead is +2, but carbon will form +4 oxidation state. Moving down the group, less availability of ns electron for formation of bond. This effect is called as inner pair effect. General electronic configuration of group 14 elements we can write ns2 np2. So outermost orbital has 4 electron, common oxidation state +4, but down the group s electron do not involved in formation of bond due to inner pair effect. So group 14 shows +4 as well as +2 oxidation state. In group 14, the first element is carbon. Carbon is the 17th most abundant element in the earth crust. This carbon obtained in the form of elementary state as well as compound. Elementary state and compound state. Diamond, graphite, coal, they made up of carbon. It contains only carbon. So this form is called as elementary form of carbon. Carbon readily combined with hydrogen, oxygen, nitrogen, sulfur, halogens to produce n number of organic compounds. Example: carbon combined with hydrogen to form hydrocarbons, one of the compound form of carbon. Carbonates, example: limestone, calcium carbonate, calamine, zinc carbonate, magnesium carbonate. So carbon obtained in the form of carbonate. And carbon dioxide gas in the atmosphere contain 0.03% of carbon dioxide. When increase the emission of carbon dioxide, it acts as a greenhouse gas which radiate the heat towards the earth. So increase the temperature, it will cause global warming. This carbon has 3 different isotopes are there. What are the 3 different isotopes of carbon? C12, C13, C14. Among these, C14 is radioactive in nature. Radioactive carbon, which is used to find out the age of fossils through radiocarbon dating. Half-life period of this radiocarbon is 5700 years. Based on amount of radiocarbon present in the fossils, they can calculate age of the fossils. Next element in group 14 is silicon. Silicon is the second most abundant element in the earth crust after the oxygen. Oxygen is the most abundant element. Silicon is second most abundant element in the earth crust. Percentage of silicon 27.7% by mass in the earth crust. Silicon obtained in two different forms, silica SiO2 and silicates. Examples of metal silicate, sodium silicate Na2SiO3, calcium silicate CaSiO3. Silicon is the important compound in cements, ceramics and glass. Next element in group 14 is germanium. Germanium obtained very trace amount present in the earth crust. Tin obtained in the form of its oxide SnO2. Lead obtained in the four important minerals PbSO4, PbCO3, lead sulfate, lead carbonate, lead oxide PbO and PbS. The name of the PbS is galena, which is ore of lead. PbSO4 anglesite, PbCO3 cerussite, PbO lead ochre. These four compounds we can call it as minerals of lead, but maximum quantity of lead extracted from galena PbS. So PbS only considered as ore of lead. The remaining three they consider as only minerals of lead. Next is periodic properties of group 14 elements. The first one is atomic size or covalent radius. When compared to the group 13, size of group 14, compact one, smaller one. Moving down the group, size of atom increases. Carbon greater than silicon, silicon greater than germanium, germanium greater than tin, tin greater than lead. From carbon to silicon, increase the size of atom due to more shielding effect of s and p orbital. From silicon to lead, small increases in size of atom due to poor shielding effect of d and f orbital. Next periodic property is ionization energy. What is the definition of ionization energy? Amount of energy required remove electron from outermost orbit of the gaseous atom. Moving down the group, size of atom increases. Size of atom inversely proportional to ionization potential. So moving down the group, ionization energy decreases. So carbon has more ionization potential when compared to the silicon. Silicon greater than germanium, germanium greater than tin. When compared to the tin, lead slightly greater ionization potential due to poor shielding effect of d and f orbital. Next is electronegativity. The definition of electronegativity: the tendency of atom attract the shared pair of electrons towards itself in a molecule. Moving down the group, electronegativity gradually decreases. Carbon greater than silicon, germanium, tin slightly increases in lead. Electronegativity of carbon is 2.5, silicon will be 1.8, germanium also 1.8, tin also 1.8, lead 1.9 slightly increases. So from carbon to silicon electronegativity decreases, from silicon to lead almost constant due to poor shielding effect of d and f orbital. Because of poor shielding, this nucleus attracts the electron more firmly. Next is physical properties of group 14 elements. Carbon is the solid non-metal. Silicon and germanium, both of them semi-metals or metalloids. Tin and lead, they are soft metals with low melting point. Moving down the group, it changed from non-metal to metallic character. Carbon is purely non-metal, silicon and germanium semi-metals or metalloids, tin and lead both of them metal, they soft metal, so they have low melting point. Next is chemical properties of group 14. The carbon family elements, they have 4 valence electrons. Outermost orbit contain 4 electrons. So general oxidation state of group 14, common oxidation state is +4 and +2. Moving down the group, +2 oxidation state stability will be increases. Example, +2 oxidation state of germanium lesser than tin, tin lesser than lead. Lead has more stable +2 oxidation state due to poor shielding effect. This +4 oxidation state, they will form covalent compound. Lead will show both +4 as well as +2. The +4 will be mostly covalent, +2 will be ionic, because oxidation state directly proportional to covalent character. When increase the oxidation state, covalent character also increases. Carbon can form maximum covalent bond of carbon only 4 due to absence of d orbital. But other element, the covalent bond can exceed more than 4. Example, SiF6 2- hexafluoridosilicate. Germanium also can form coordination number 6 hexachloridogermanate. So other elements apart from carbon, the heavier elements can exceed the covalent bond more than 4, but carbon restricted to only 4 due to absence of d orbital. Next is group 14 elements. Reaction with air, 14 elements with air. Generally, group 14 elements combine with oxygen to produce monoxide and dioxide. Action with air. When carbon ignited, insufficient amount of air to produce carbon monoxide. Similarly, silicon will form silicon or silica SiO, but it exists only at high temperature. Germanium can form monoxide, tin also will form monoxide, lead also will form monoxide. All other group 14 elements they can form dioxide, carbon dioxide, silicon dioxide, germanium dioxide, tin dioxide, lead dioxide. Carbon dioxide, silicon dioxide, germanium dioxide all are acidic in nature. The nature of the oxide is acidic in nature, but tin dioxide and lead dioxide is basic in nature. Metallic character, so the basic in nature, they can react acid as well as base, so they can call it as amphoteric oxide. Similarly, tin oxide, lead oxide, amphoteric in nature. Carbon monoxide is neutral. When carbon dioxide dissolve in water to form carbonic acid, but carbon monoxide do not give any acid, so it is called as neutral oxide. Germanium oxide is acidic in nature. So a group 14 elements combine with oxygen to form two different types of oxide, monoxide and dioxide. Among these, carbon dioxide, silicon dioxide, germanium dioxide acidic in nature, tin and lead oxide amphoteric in nature. The meaning of amphoteric, it can be react acid as well as base. Next is group 14 react with air. Next is group 14 element reaction with water. Reaction between group 14 and water. First three elements, carbon, silicon, germanium. No reaction with water. They do not affected by water. But tin can be react with water to form corresponding oxide SnO2. So 2 molecule of water plus 2 H2O, but it should be in the gaseous state. Tin affect only with steam, not ordinary water, to form corresponding oxide SnO2 and liberate hydrogen. Lead also there is no reaction with water. The reason is lead will be surface of lead will be covered with oxide, lead oxide. It forms protective layer of lead oxide which prevent further affection of other water and acid or base also. Next is group 14 elements with halogens. Group 14 elements readily combine with the halogen to produce compound except carbon. Action with halogens, silicon, germanium, tin, lead. They directly react with the halogen to will give two different types of compounds, dihalide and tetrahalide. Like this, carbon do not react with the halogen directly, but we can prepare carbon halides when react with methane. Chlorine react with methane in presence of light, we will get chloromethane. Like this, all the four hydrogen can be replaced by chlorine. Finally, we will get tetrachloromethane in presence of light. This reaction is called as photolytic substitution reaction. But other elements from group 14, they directly combine with halogens to produce di and tetrahalides. Among this di and tetrahalide covalent in nature, but dihalide ionic in nature, predominantly ionic in nature. Germanium will give two different types of halides, germanium tetrafluoride and germanium difluoride. The stability of germanium tetrafluoride greater than germanium difluoride. Tin also will give two different types of fluorides, tetra and difluoride. Among these, dihalide will be more stable due to inner pair effect, similar to the lead. Lead also difluoride only more stable due to inner pair effect. Generally, tetrahalides of group 14 hydrolyzed by water to produce coordination compounds, but carbon tetrachloride do not undergo hydrolysis because it's an electron precise compound. It do not accept lone pair of electron from water, but other halides involved in hydrolysis to form coordination compounds. Example, silicon tetrachloride. Molecular formula of silicon tetrachloride SiCl4 involved in hydrolysis. All the four chlorine can be replaced by hydroxide ions. Name of the acid silicic acid plus 4HCl. When silicon tetrachloride hydrolyzed by water will get silicic acid and hydrochloric acid. Next is anomalous properties of carbon. Carbon differ from its own group elements due to compact size, higher ionization potential, higher electronegativity, absence of d orbital. So carbon deviate from its own group elements. The reason is higher ionization potential, more electronegativity, absence of d orbital. Example of some anomalous property of carbon. Carbon can form p-pi multiple bond with carbon or some other second period elements like with oxygen, nitrogen. So they can form p-pi multiple bond, but heavier element cannot form p-pi multiple bond. They can form only d-pi or else d-pi only. Maximum covalence of carbon only 4 due to absence of d orbital. It can utilize only ns2 electron and np2 electron, so maximum covalent bond only 4, but heavier element can be utilized d orbital also. They can expand the coordination number till 6 also. So this is the another different property of carbon from its own group elements. Next is catenation. Carbon is the most catenation element in the planet Earth due to small size and tetravalency. Because of small size and tetravalency, this carbon readily combine with hydrogen, oxygen, nitrogen, sulfur, chlorine, bromine, iodine to produce millions and millions of compounds. This property is called as catenation. That is why carbon is called as most versatile element. Next topic is allotropy or allotropes. What is the meaning of allotropes? Same element exists more than one different physical properties. Example, carbon has two different solid form. One is amorphous, another one is crystalline. What is the difference between amorphous and crystalline? In amorphous, The atoms are arranged in irregular manner or random arrangement, but in crystalline they arranged regular manner and long range order, but amorphous will be short range order. Example of amorphous form of carbon: coal, coke, charcoal, lamp block. These are the amorphous form of carbon. Crystalline form of carbon: diamond, graphite and fullerene, because they are regular arrangements of atom in the crystal lattice. That is why they are called as crystalline form of carbon. The definition of allotropy: same element exists more than one different physical form. Example, carbon, it's a two different form is there, amorphous and crystalline. Coal, coke, charcoal, lamp block, they come under amorphous. Diamond, graphite, fullerene, they come under crystalline. Even sulfur also has allotropes: rhombic sulfur and monoclinic. Phosphorus also different forms are there: white phosphorus, red phosphorus and black phosphorus. Diamond. In diamond, each carbon bonded with 4 other carbon atoms. In diamond, each carbon bonded with 4 other carbon atoms. The distance between 2 carbon atoms in diamond is 154 picometer. It has sp3 hybridized carbon atom. They have linked with strong covalent bond. Due to that, diamond is the hardest substance on the planet Earth. All the 4 electrons involved in the formation of bond, so they do not conduct electricity. The other side, graphite. It is a hexagonal sheet structure. In graphite, each carbon bonded with 3 other carbon atoms. So it has one delocalized pi electron. It acts as a good conductor of heat and electricity. So graphite is the only non-metal can conduct electricity due to delocalized electron, because only 3 electrons involved in the formation of bond. The distance between 2 layers of graphite is 340 picometer. Distance between 2 carbon in the graphite is 141.1 picometer. These 2 layers held together by weak van der Waals force. So graphite is soft in nature. Because of that, graphite acts as a dry lubricant. It has sp2 hybridized carbon atom. The next allotropic form of carbon is fullerene. It's a spherical shape. Preparation of fullerene: when graphite in presence of noble gases heated in electric arc in presence of argon, which prevent the oxidation, you will get C60. This C60 spherical in shape, or football or soccer ball shape. It contains 20 hexagons. Fullerene contains 20 hexagons, 12 pentagons. This hexagon can be fused together with other hexagon or pentagon, but pentagon can be fused only with hexagon. It cannot be joined with another pentagon. This is a structure of fullerene. Fullerene contain both single bond and double bond. It is a spherical in shape. This pentagon can be fused only with hexagon, but hexagon can be joined together with other pentagon and hexagon also. So two important allotropic form of carbon is amorphous and crystalline. Under the crystalline, we discussed diamond, graphite, fullerene. Fullerene, one of the pure form of carbon. While heated the graphite in presence of noble gases, we will get C60. It contains 20 hexagon, 12 pentagon. This hexagon can be fused with another pentagon or else hexagon, but pentagon can be fused with only with hexagon. Geometry will be spherical shape or football shape. Next is important compounds of carbon. First one is carbon monoxide. Molecular formula of carbon monoxide, CO. First one is preparation. When carbon heated in insufficient amount of air, we will get carbon monoxide. Next one is when coke treated with steam, water in the gaseous state at 1273 Kelvin, you will get mixture of carbon monoxide and hydrogen. They collectively called as synthesis gas or syn gas. When coke, this hard coke treated with air, it contains oxygen and nitrogen, heated at 1273 Kelvin, you will get mixture of carbon monoxide and nitrogen. This gas is called as producer gas. This carbon monoxide highly poisonous because it can make bond with hemoglobin 300 times greater than oxygen. So it prevents the supply of oxygen. It will cause death immediately. Another use of carbon monoxide, it used in extraction of metal. So another important material in metallurgical process. Example, hematite. Molecular formula of hematite, ore of iron, Fe2O3. When treated with carbon monoxide, this oxide will be reduced to iron, ferroferric oxide reduced to iron, carbon monoxide oxidized to carbon dioxide. Similarly, when zinc oxide treated with carbon monoxide, zinc oxide reduced to zinc, carbon monoxide oxidized to carbon dioxide. So carbon monoxide acts as an important role in metallurgy. Next important compound of carbon is carbon dioxide. Molecular formula of carbon dioxide, CO2. While heating coal, we can produce carbon dioxide directly. It's one of the exothermic reaction. Combustion reaction. When methane ignited in presence of air, it produces carbon dioxide, water and heat. Total number of oxygen in the reactant side 4, so 2O2. This reaction is called as combustion reaction. Any one of the metal carbonate, example calcium carbonate, treated with acid, you will get corresponding salt, calcium chloride. So we will take 2 molecules of hydrochloric acid. These 2 hydrogen combine with one of the oxygen to form water and liberate carbon dioxide gas. When calcium carbonate treated with hydrochloric acid, brisk effervescence is evolved due to liberation of carbon dioxide to form corresponding salt, calcium chloride. This carbon dioxide acidic in nature. When carbon dioxide dissolve in water to form carbonic acid. CO2 plus H2O to form carbonic acid, molecular formula H2CO3, which is dibasic acid. It contains two replaceable hydrogen atom. This carbonic acid will be ionized like this: H2CO3 in presence of water to form hydronium ion and HCO3 minus plus hydronium ion. This bicarbonate ion can produce one more proton, so it will become CO3 2 minus plus hydronium ion. This buffer action between carbonic acid H2CO3 and HCO3 minus ion maintain the pH level of blood 7.23 to 7.48, slightly basic. This carbon dioxide also used in photosynthesis reaction. Plant synthesize the food in presence of light, so this reaction is called as photosynthesis. Example, carbon dioxide plus water in presence of light, H nu. Chlorophyll act as a catalyst, green pigment. We will get a glucose C6H12O6 plus oxygen gas is liberated, 6CO2. We will get 6 molecule of oxygen is liberated. This reaction is called as photosynthesis reaction. Next is some important compounds of silicon. Example, when silicon tetrachloride treated with water, we will get silicic acid. Molecular formula of silicic acid SiOH4. Due to steric hindrance, undergo dehydration, minus 2 molecule of water, the silicic acid will be converted into silica. When dialkyl dichlorosilane treated with water, we will get silicone polymer. Dialkyl dichlorosilane, name of the compound dialkyl dichlorosilane, hydrolyzed with 2 molecule of water, we will get 2 hydroxide active side chain plus 2 HCl. This active side chain hydroxyl group extend the chain structure, we will get long polymer chain SiRROH. They join together through condensation. This OH can extend the chain structure. This polymer is called as silicone polymer. When dialkyl dichlorosilane involved in hydrolysis, we will get 2 active side chain OH. This side chain OH joined together with another molecule through condensation, then extend the chain structure. This polymer is called as silicone polymer. Next is trialkyl monochlorosilane. Structure of trialkyl monochlorosilane R3SiCl involved in hydrolysis. We will get R3SiOH. This trialkyl, one active side chain is there. They join together through condensation with elimination of water molecule. We will get hexaalkyl siloxane. Name of the compound is 6 alkyl group is there. That is why it is called as hexaalkyl siloxane plus water. The next combination is trichloroalkyl silane. Alkyl trichlorosilane. Structure of alkyl trichlorosilane are SiCl3. When treated with 3 molecules of water, all the 3 chlorine should be replaced by OH hydroxyl ion. We will get cross-linked polymer like this, or SiO Si or Si or Si. These two silicon bonded through oxygen. This polymer is called as cross-linked polymer. When silicon tetrachloride hydrolyzed with water, we will get silicic acid. This silicic acid undergo dehydration, we will get silica. Dialkyl dichlorosilane involved in hydrolysis will get 2 active side chain OH group, which extend the chain structure. Will get long chain polymer called as silicone polymer. When trialkyl monochlorosilane involved in hydrolysis, then undergo condensation, we will get hexaalkyl siloxane. Alkyl trichlorosilane hydrolyzed with water undergo condensation to form cross-linked polymer.